Hello and welcome to the Online College of Coding video tutorial series. This is video 4 in the series on getting started with Unity 3D. In this video we'll be looking at some more advanced C# programming concepts. Before starting in this video we recommend that you've watched video 3 in this series so that you understand the basics of creating a C# script. So let's get started. Let's have a closer look at some of the C# variables or data types that we have available to us. There's many different types of data in C#, and there's many different ways of storing that data, whether it's a whole number, or a decimal, or simply a true or false. Remember that in your scripts, any raw data, like the letters or value numbers for variables, will always appear in orange. The main data types in C# are ints, floats, bools, chars, or strings. The name int is short for integer, and integer just stores whole numbers. A float is short for floating point, and a floating point number is capable of storing decimal numbers up to 7 digits long. A bool or boolean can be equal to either true or false. A char is short for a character, and it can store single characters like letters or symbols. A string is a string of characters, and that could be a word or a whole sentence. You declare all variables in the following way. The dark blue word is defining the variable type, that is, the type of data that the variable will hold. The orange text is the raw value of the data that is being stored. The black word is the name that we are giving to the declared variable. Remember, variables must start with a letter, they can't have any spaces, and they need to be clearly identifiable for the purpose for which they are being declared. Now Unity has a number of its own data types. Most of the data types in Unity are a combination of several ordinary C# data types put together to suit a specific purpose. We'll just look at a number of the main Unity data types that we'll need to understand. These data types within Unity are accessed from the inspector. Starting with the vector data type, this is most commonly associated with the transform component in the inspector. A vector data type is created using a combination of several floating point variables. The most common of these is a vector 2 and a vector 3. A vector 2 uses two floating points to represent the x and y axes in a 2D game, whilst a vector 3 uses 3 to represent the x, y and z in 3D games. Another is the rigid body data type, which gives physical attributes to game objects, such as mass and gravity and drag. Rigid body components link their game objects up to a physics program called PhysX that calculates all of the collisions and forces that these game objects are involved in. The mass of a rigid body data type would be using a floating point C# variable, whilst the use gravity would be using a boolean to indicate true or false based on whether the box was ticked or not. The collider data type is another component like the rigid body. A collider component detects collisions on the designated area, but is not as accurate as rigid bodies. They come in different forms like boxes and spheres, and capsule colliders for most of the 3D shapes, and then there's also mesh and polygon colliders which could be used for the more complex meshes. Whether the collider is acting as a trigger would be using a boolean C# data type, whilst the center and the size of the colliders would be using floating point data types. For the mesh filter data type, when any object has a mesh, like say a 3D game character, the mesh filter holds onto it and passes it to the mesh renderer so that it can get drawn. The mesh filter is where you assign a mesh to a game object. With the renderer data type, there are mesh renderers for 3D objects and sprite renderers for 2D sprites. And these built-in data types are used to calculate how objects will be rendered to the screen based on values of other variables such as lighting or shadows. And the animated data type is a component that links game objects to an animation sequence so that it can animate in the scene. So let's add a few more lines of code to our bounce script that we created in video 3 to see how these Unity data types work. Once again, you can either open the accompanying tutorial document and copy and paste the code, or you can pause the video here and type in the code from the screen. Let's have a look at our two new lines of code. The first line we've just added creates a random color. The new random color is stored as a vector3 called myColor. This is because in computer language all color is made up of a combination of red, green and blue, all represented as floating point values between a value of 0 and 1. We use the x, y and z components to make up a vector3. This represents the color because they're floating point values as well. To do this we use a bit of a trick. When we fill in the values of our myColor vector3, we use random.InsideUnitSphere. This gives us a vector3 comprised of random values between 0 and 1. Then we can tell the computer to use these values to create a color. The second line of code uses the function GameObject.getComponent. This accesses the GameObject's MeshRenderer component. It then accesses the renderer's material and changes the color to the new color. Unity is American, so it uses COLOR instead of COLOUR. And this is made from the myColor, which is our random color from our first line of code. The next very important thing to look at is the if statement. Now our script contains an if statement. Computers run scripts pretty much the same way as if you're reading a book. They start at the beginning of the script and read through word by word, line by line from left to right all the way through to the bottom. But an if statement can be used to make the computer jump to different sections depending on whether or not an if statement is true or false. If we use a little example, like if we were reading our own book, we could go something like this. If we got our book and we were up to chapter 3, we would turn straight to chapter 3 and start reading there. Else, if we had a bookmark and it was sitting at page 78, we'd turn straight to there and keep reading. Else, if we weren't up to chapter 3, and if we didn't have a bookmark, we'd just start reading straight at chapter 1. These if and else if keywords are used to be able to make the computer skip to certain parts of the script depending on whether certain variables or conditions have been met or not. So we can see in our script that this section of code here between these two parentheses will only be run if this if statement here, which is a Boolean logic test condition, if that tests as true, then this will run. If it doesn't, this section of code will never get run. So in other words, our colors won't change and our objects won't jump if we haven't pressed spacebar. Now, critical to understanding how C# scripts work is understanding what a function is and does. This if statement of ours exists inside this update function. A function is a complete section of code responsible for doing something that needs to be done more than once, or maybe in multiple locations. Instead of having the same section of code repeated over and over within the script, the function which does this job can simply be called. By default, when we create our C# scripts, we start with the start function and the update function. But you can create your own functions as long as you adhere to the following rules. A function must have a unique name. When you declare the function, it has to have a data type, and then the code for your function must exist within pairs of parentheses. Now, building on this, because our script has been created from a template called MonoBehavior, there are a number of predefined functions, which are also known as methods, that exist as part of MonoBehavior that we can borrow and add to our script because it is a child of MonoBehavior. The start and update functions are examples of these predefined methods. Two of the most commonly used other methods are onCollisionEnter and onTriggerEnter. The onCollisionEnter function will be called on the first frame that a collider or rigid body begins intersecting with another collider or rigid body. The onTriggerEnter function will be called on the first frame that a collider or rigid body begins intersecting with a trigger. These two predefined functions or methods are very handy when creating games because they can be used for actions like jumping and landing, or shooting and dying, or collecting power-ups, and a whole range of other game-based actions. So now that we know about the methods that are available in MonoBehaviour, let's add one to our bounce script. Find where the closing parenthesis is for your update function, and just after it, but before your final parentheses, insert the following code. So either refer to your associated tutorial documentation and copy and paste the code, or press pause now and type the code yourself by copying what you can see on screen. In this newly added code, the onCollisionEnter function will be called when there's a collision. During that collision, we check what's been bumped into, and then we change its material color to the material color of the object it collided with. So we can test the effect that these new lines of code have on our script by saving it and returning to Unity and clicking play. And now if we jump, they change colors, and if they collide, they also change colors. Before wrapping up this video, it's worth mentioning commenting. It is good practice to add comments to any piece of code or script that you write. By commenting your code and providing details of the purpose of the file or segment of the code, these comments greatly assist anyone who is reading it in trying to understand what the programmer was doing. Any comments you add to your code won't affect the script. The compiler ignores the comments when it builds the solution. There are two basic ways to add comments to your code. First of all, there's the double backslash. This is used for single lines of commenting. The other method to use is for multi-line comments. That started with a slash asterisk and finished with an asterisk slash. Any text in between the asterisk slashes becomes a comment. And that concludes this video and this 4-part series on getting started with Unity. By now you should be confident with navigating your way around Unity and MonoDevelop to create some basic game objects and C# scripts. If this is your first time using Unity and C#, there's been a lot to learn in these videos, so you may want to go back and re-watch videos 2 to 4 before starting on one of the intermediate game development projects that use Unity and C#. Otherwise, if you're ready to move on, you can start one of the intermediate level Unity projects.